A pleasant greetings to all. In this video, I am going to solve some important multiple choice questions in electrical and electronic measurements. The problem number 1. Match the following list 1 with list 2 using codes. The first one, closeness with which an instrument reading approaches the true value. Closeness, that is the representation of accuracy. And next, a measure of the reproducibility of the measurement, that is precision. The ratio of output signal or response of an instrument to a change of input is an indication of sensitivity. The last one, the smallest change in the measured value to which the instrument will respond, that is resolution. Problem number 2. A 0 to 150 voltmeter has a guaranteed accuracy of 1% full scale reading. The voltage measured by this instrument is 83 volt. The limiting error in present will be. Okay, here 0 to 150 voltmeter, 1% error, and the voltage measured is 83 volts. So what about the error? Okay, first of all, I am going to find out the magnitude of error. How to find out the magnitude of error? Here the 150 is the voltage. The error percentage, that is accuracy, is 1%. So 1 divided by 100, that is 1.5. So 1.5 is the magnitude of error. And next I am going to find out limiting error. So how to find out limiting error? 1.5 divided by the value given is 83 into 100. Okay, then in denominator 150 divided by 83, that will give the value 1.80 value. So the answer B is the correct one. Next one, which of the following meters has the best accuracy? Always the moving coil meter that gives the best accuracy. Moving coil or permanent magnet moving coil. Next, question number 4. AC current cannot be measured directly by moving coil because the permanent magnet moving coil instrument which is used to measure DC only. Next question, which of the following instruments will read true RMS value irrespective of signal waveform? Signal waveform, if it is sine, square, rectangular, short tooth, any other waveform is there, but the thermocouple meter that will produce the true RMS value. Next question, which of the following is not a current meter? See, the moving coil is a current meter, hot wire type also current meter, thermocouple is the meter, current meter. So none of these is the correct answer. Next, which of the following meters cannot measure DC? Moving coil meter can measure DC, dynamometer DC and AC, moving iron meter also DC and AC, and rectifier type moving coil meter, that is AC only, does not measure the DC signal. Next, which of the following meters cannot measure both DC as well as AC? Induction type meter, because the induction type meter measure AC only, but 3 type meters AC and DC both are measured. Next question, the internal resistance of the voltmeter should be very high in order to have minimum current through the meter. If the resistance is high, then only the minimum current is flowing. Next question, the internal resistance of an ammeter should be very low in order to have minimum effect on the current in the circuit. That is the correct answer. Next, hot wire ammeters are used for measuring both AC and DC. Next, which of the following meters is an integrating type instrument? Energy meter which is used to record the particular days where values are recorded. So that is energy meter. Next, an electrodynamometer type of instruments finds its major uses both as standard and transfer instruments. Next, electrostatic instruments are used for AC and DC voltage only. Next, rectifier type instrument can be used in AC only. Dynamometer type instrument can be used in AC and DC. Which one of the following type instruments does suffer from error due to magnetic hysteresis? That is moving iron meter. Next, a generated voltages equally depend on the three resistance R1, R2 and R3 and its value B is equal to R1, R2 divided by R3. If tolerance of each resistor is 0.1%, what will be the maximum error in voltage? The voltage given is R1, R2 divided by R3. Here 0.1 is given. So in denominator we are having two values in multiples. So we have to multiple 2 into 0.1 plus or minus 0.1% plus R3 is what? Again 0.1%. Now summed up all this we get 0.3%. So this is the correct answer. Next, which one of the following statements correctly responds the systematic error? These errors can be calculated from the details of the instrument. Next question. Swamp resistance and condenser are used to reduce error while measuring DC quantities in a moving iron instrument. But the swamp resistance is mainly used in moving coil instrument. So to reduce the error while measuring DC quantities in a moving coil instrument. Next question. For accuracy of the instrument which is necessary, precision and conformity both are necessary. So both is the correct answer. Next, energy meter runs slowly even if power is not used. This error is called creeping error. Next question. The null type instrument as compared to a deflecting type instrument, null type instrument has higher accuracy. Next, the ratio error in current transformer is due to exciting currents. Next, to minimize the errors due to lead and contact resistance, low resistance used in electrical measurement work are provided with 4 terminals is the correct answer. Next, a 150 volt moving iron voltmeter accuracy 1% reads 75 volt when used in circuit under standard condition. The minimum possible percentage error in the reading is. So first of all we are going to find out magnitude of error. So what is the magnitude of error? The magnitude of error equal to 150 into 1 by 100. So here you have to multiply this, then 15 by 10, 1.5. This is the magnitude of error. What is the maximum percentage of error, possible percentage of error? That is equal to 1.5 divided by 75 into 100. So that is 150 divided by 75. So this is the percentage value. The answer is 2%. And next, in order to achieve accuracy, how should the slide wear of the potentiometer be? As long as possible. Next, torque to weight ratio of an instrument indicates sensitivity. And next, 0 to 10 ampere ammeter has a guaranteed accuracy of 1% of full scale deflection, the limiting error while reading 2.5 ampere. So first of all, we have to find out magnitude of error. So how to find this? 10 into 1 by 100. This is the magnitude of error. So 1 by 100. So that value is 1.1. Okay, next, how to find out the limiting error? So limiting error is 0.1 divided by 2.5 into 100. So what is the value? 10 divided by 2.5. So 100 divided by 25. That is 4 is the correct answer. Next, the voltage 2.70 volt is being measured by an analog indicator instrument having a scale range of 0 to 5 volt. If the instrument reads 2.6 volt, the absolute error. What is the absolute error? The absolute error is true value 2.70 minus measured value 2.65. So the answer is 0.05 volt. This is the correct answer. Next, the current I through a resistance R is measured with the following uncertainties. I is equal to 4 ampere plus or minus 0.5%. R is equal to 100 plus or minus 0.2%. If power is computed from these two measured quantities, the uncertainty in the power computed will be. So P is equal to what? I square into R. So what is I? I is equal to 0.5%. So 2 into square means you have to write like this, 2 into plus or minus 0.5%. Okay, then plus or minus 0.2%. Now we have to add this, we get 1.2%. So this is the answer.